This screencast will finish the Module 2 wrap-up that I didn't finish in class. So we're asked here if the person initially is working 40 hours a week at $30 an hour and has, by this calculation here, is spending 128 hours a week in free time, including sleeping, eating, cleaning the house, etc. Now the wage rate goes up by 20%, and this person wants to keep the total weekly income constant. What's true? So we have to figure out, to answer this question, we have to figure out how much does the person have to work to keep income constant. So the way you do that is figure out what income that we'll call M naught, and that's going to stay the constant. If I'm working 40 hours per week at $30 an hour, I'm going to be making $1,200 per week initially. So now what's going to happen is we're going to get a raise of 20%. So 10% of 30 is 3, 20% of 30 then is 6, and if I'm getting a $6 an hour raise, my new wage rate is going to be $36 per hour. So now the question becomes, I know I want to keep my income at $1,200. How many hours is that? So $1,200 would now be some hours H, we don't know it yet, but times our $36 an hour. If I divide both sides by 36, I could solve for H. And so H is equal to 1,200 divided by 36. That's how many hours I work, and when I put that into my calculator, I get 33.3 hours per week. All right, well that's what I need to know. So now my total hours per work will fall by 20%. Let's think, is that right? Well, it was 40, so 20% would be 8. Didn't fall by 8 though. No, so we can rule out, hey, it only fell by 6.7 hours. Your total number of working hours per week will be 30.8. Well, that's not right. It's 33.3. Your total number of free hours will increase by 20%. Well, 20% would be, that's roughly 26 hours. And we know that our leisure time, our work went down by 6. So now our free time, 6.7, would be 128 plus that 6.7 hours we're not working anymore, and that's 134.7. That was where the typo came in somehow. I did that math, had that on my scratch paper, and somehow what came out of my fingers was 144.7. Dumb. Anyway, our total free hours will increase by 20%? No, they increase by 6.7, but that's way less than the 26 hours they would have increased if they increased by 20. So the only one that makes sense is D. So the correct answer was D. Here, this one was the one that most students missed, and I think most students missed because of not realizing that 3 was true. But the average point at any function of the slope is a line drawn, is the slope of the line drawn from the origin to the point of the function. And that's true, right? Because the slope of this line would be your final exam mark. That's change in the rise over run is slope. That's the vertical distance. And then the x-axis distance would be hours studied. So that's points per hour. That's the average product. On average, how much did each hour spent studying increase your grade? And that's by definition the slope of the line from the origin to the point in the curve. The marginal product at any point on the function is the slope of a line tangent to the function at that point. That's also the definition of the marginal product from the reading. If I want to know how much that 4th hour increased my grade, I could get it exactly by taking the slope of the function at hours of study equals 4, final exam mark 50. And then finally, let's look at number 3. if Alexei studies for 4 hours per day, so he's at this point, he's got a 50 on his exam, and he's going to increase his study to 5 hours a day. What does that do? Well, it brings his study hours to 5, and it brings his score up to, that looks like 57. So we're going to say answer D. I can't write D. 1, 2, and 3 are all correct. And then this one, I don't think anybody missed this, but this is such an important framework that I'm going to just march you through it real quick. Which of the following is true? I'm going to use my pointer, not my right. Alexei prefers C to B because he has more free time. C over B. Well, he does have more free time, but B is on a higher indifference curve, so that's giving him more satisfaction. So he'd prefer B to C because B is on a higher indifference curve. Alexei prefers A to H, because he has a higher grade. Well, he does have a higher grade at A than he does at H, but they're on the same indifference curve, so by definition, he likes A and H equally well, so he doesn't prefer A to H. C. Alexei prefers D to C. Let's look at that. D to C. Well, D is certainly preferred to C because at D he has the same grade and more free time. No. He has the same free time, but a higher grade at D. So our rationale at C is wrong. And then finally E. At E, could E be true? At E, if he's willing to give up 1 hour of free time, that would move him from E to F, for 9 extra grade points. And is that plausible? Could that be 64? Yeah, that looks like it's 14/25 of the way from 50 to 75. D could be true, and it's the only one that could be true. So we're going to say D, just because we've unquestionably eliminated everything else. And then finally, I think most of you got this one too, but still, it's an important concept. Here, you're this Uber driver, and you're earning $100 per day working as an Uber driver. And you've got this one-day ticket to the U.S. Open tennis tournament, $75, and the experience of going to the tennis tournament is worth $200 to you. So what can we say? Opportunity cost of the day at the U.S. Open is $75. No, that's not true. The opportunity we're giving up is working and making $100. The economic cost, I actually see economic cost and opportunity cost as synonymous. I think our authors describe the opportunity cost as the loss of the 100 and then the money out of pocket on top of that, and the economic cost is the sum of both. I see the money out of your pocket as an opportunity cost too, because you could have spent that money on something else. So you've lost whatever you would have spent the $75 on. Anyway, I'll not emphasize that distinction. But in any case, neither one of these is right. In my world, the opportunity cost and the economic cost would both be $175. The $100 per day you didn't earn because you took the day off to go to the Open, plus the $75 the ticket cost you. The economic rent, let's check the economic rent of the day at the U.S. Open is $25. Well, the economic rent is defined as the value of the option taken minus the value of the reservation option. I didn't write all that out. Well, the value of the option taken is your $200 enjoyment of the U.S. Open less the $75 costs. So that's $125. On the value of the reservation option, which is given at 100. So if you take 125 minus 100, you get 25. Economic rent is 25. Bingo, that's true. Just to rule out D, you would have paid up to 125 for the ticket. No. You would have paid up to 100, right? If the ticket cost you 100, you'd be just indifferent between your value of the option taken and the reservation option, value of the reservation option. But if the price were 125 a ticket, you would have just said, forget it. I'd rather work than get $75 worth of surplus going to the Open. So that's that one.